Heyo, welcome. This is 7.2b. Let's do this. We're going to simplify the following. Now, oh boy, we're adding these things, but what I notice is that there's 7x to the third roots, and plus there's 2x to the third roots. I notice that the base and the power, or the index and the radicand, is the same. Like, these are exactly the same right here. So I think of these as like terms. Exactly, it's the exact same value. So I have 7 of them to the left, and I have 2 of them to the right. So I can combine them and say that there are 7 plus 2 is 9. So there are 9 of them being these thingies. Beautiful. Same here for number 2. Notice that this term, that's like z to the 3/2, that's exactly the same as that one. The exact same terms. Now we're taking 3 of them and we're subtracting 7. Oh man, 3 minus 7. You can't do that. Well, you get -4. So there's -4 of those things. Of those z to the square root to the third power. Same idea in this one. X to the 1/5, x to the 1/5. There's -3 of them over here on the left, but we're adding 2 of them on the right. So when I add that together, I get -1. But you don't really need to write the 1, so just a negative x to the 1/5. You don't need the 1, that's why it's dashed. You don't really write it, but you can. It's not wrong, it's just redundant. It won't be on the ACT multiple choice option to have a 1 there, so don't freak out when you have a 1 and just realize it's the same as not having a 1. Alrighty. Hey, I thought it'd be good to go here. So, alright, so number 4, think of it as this way. I have 50 raised to the second power, the 1/2 power, excuse me. I'm taking the square root of 50. So what you want to do is think about, is there a number, a factor of 50 that is square rootable? So really you're taking your numbers and you're thinking of your square roots here. So 25 is a square root, and that is a factor of 50. So I'm going to rewrite this as the square root of 25 times the square root of 2. So then that's the same as 5 square roots of 2. Now same idea here for number 5, but now we're going to think about cube roots and third powers. So 2 to the third power is 8, 3 to the third power is 27, 4 to the third power is, 64. So what I'm thinking is, since we're in cube root land, is there a whole number that's a factor of 81? Is there a cube root that's a factor of 81? And so when I'm looking at these, 8 doesn't go into 81. 3 to the third is 27. That does go into 81. So I can rewrite this as the cube root of 27. Why is that important? Because I can cube root 27 and get a whole number. But hold on, it's the cube root of 27 times the cube root of 27 times what is 81? 3. So what you would do is you'd look at these numbers and see if you can multiply them up to 81. Yes, 27 times 3, so that's where I got this 3. And again, they all have to be cube rooted. Now the cube root of 27 again is the whole number 3. The cube root of 3 I can't break down anymore, so that's my final answer. So now I'm thinking fourth roots. 2 to the 4th power is 16. 3 to the 4th power is 81. 4 to the 4th power is, I don't even know. It's like 200, let's see, 16, 64, 264, I want to say. I don't know. Doesn't matter because it's way over 162. So, hey, 81 times 2 is 162. So I'm going to break this up into 81 times 2. But remember, this is the 4th root land. So it's the 4th root of 81 times the 4th root of 2 that is equivalent to the 4th root of 162. And again, I was living in the powers of 4 because 3 to the power of 4 is 81. That means that 3 to the power of 4, 4th rooted, is 3. Oof. what number times itself 4 times is 81? 3 is. And this fourth root of 2 I can't simplify, so I just bring that down. Fourth root of 2. There we are. Same idea here. We can break these apart. This is the same as the square root of 16. You can put a 2 up there if you want, but you don't have to. It's assumed if you don't see a index number that it is a 2. So I broke apart the square root of 16 times the square root of 4. So now the square root of 16 is 4, and what times itself twice is x to the fourth? X to the second. X to the second times x to the second is x to the fourth. So that is the square root of this value. Same thing here. Let's break this apart. The cube root of 12 times the cube root of x to the third. Well, what number times itself 3 times is 12. 2 to the third is 8. 3 to the third is 27. I can't factor an 8 out of 12. 27 doesn't go into 12. So I'm stuck with this cube root of 12. But what times itself 3 times is x to the third? X. Now I'm going to actually put that in front since it's not in the radical. So there we are. X times the cube root of 12. Alrighty, so let's break this apart. We got the fourth root of 20. Got the fourth root of x to the fourth. And we got the fourth root of y to the fifth. Now check this out right here. I'm going to rewrite this as the fourth root of y to the fourth times the fourth root of y to the 1. Right? Like, this right here is the same as y to the fourth times y to the 1. So I broke that apart again. What number times itself 4 times is 20? Doesn't really exist. So I'm going to rewrite the fourth root of 20. What value times itself 4 times is x to the fourth? That's just x. I'm going to put that out in front. And now the fourth root of y to the fifth, ooh, I don't want to think about that, but look how I cleverly broke the fifth root, y to the fifth apart. I was able to write it as y to the fourth times y. So the fourth root of y to the fourth, or what thing times itself 4 times is y to the fourth, is y. And then over here we have the fourth root of y. Got to bring that along. Fourth root of y. That's a 4. I apologize. Last couple. Let's try. So recall that when we take a power to all these factors, we sprinkle that power in. So this is the same as 8 to the 1/3, or the third root of 8. So what number times itself is 8? That's what I'm thinking. I'm going to get to that in a second. When we have a power raised to a power, we multiply the powers together. So 6 times 1/3, or a third of 6, is 2, and a third of 3 is 1. So it's v to the 1. And I'm sorry, when I said a third of 6 is 2, that's the power on the base, which I changed from a u to an x. Let's bring that back. Hey, you, get back here. Get that x out of there. That didn't really make sense. All right, so again, let's try to simplify this now. The cube root of 8 is 2. I've already really simplified this u squared. I can't simplify anymore. V to the 1, I don't have to write the power of 1. Just leave it like that. All right. Similarly, I can take that cube root and break it apart and put it to the top and to the bottom. So that's what the top looks like. This is what the bottom's going to look like. So the cube root of 8 to the third means what times itself 3 times is 8 to the third. That would just be a. And here the cube root of b to the 9 means what times itself 3 times is b to the 9. That one might be a little bit tougher. You know what we can do here, folks? Let's take this thing right here and rewrite it in rational exponent form. So my power is 9 and my denominator is 3. So it's really this. That's the same way as writing. It's the same thing as writing b to the 9�3. What's b to the 9�3? That's 9 divided by 3 is 3. So I get a b to the third on the bottom. And maybe you were thinking, well, b to the third times b to the third times b to the third. In other words, b to the third times itself 3 times is b to the 9. That's cool. If you didn't need to do this, you didn't have to. But it's cool. It helps us see a different way of getting the right answer, or confirms it perhaps. Or it's how we get it, because this part is confusing. It's the beauty of being able to walk between these two systems of a radical and a power written as a fraction, rational exponent. Beautiful. Need a Kleenex.